let's look at this problem. So evaluate the limit extends to 1 by e power ln of 1 plus ln x by x minus 1 by e. So see here, so first what is given is limit extends to 1 by e power ln of 1 plus ln x by x minus 1 by e. So let's say this is x tends to 1 by e, right? So ln x tends to minus 1. So 1 plus ln x tends to 0. So ln 0 will tend to minus infinity. So minus infinity by x. X is 1 by e. So this is again minus infinity. So e power minus infinity will tend to 0. 0 by 1 by e minus 1 by e, 0. So this is 0 by 0 form. So we cannot directly evaluate the limit. So if I substitute x equal to 1 by e, I will get 0 by 0 form. So substituting x equal to 1 by e, we are getting 0 by 0 form. So what we do is, we'll try to transform this limit to some limit which can be evaluated. So first what we do is, x minus 1 by e is equal to t. So let's say if I consider x minus 1 by e equal to t. So then t tends to 0, right? So limit t tends to 0 e power ln 1 plus what is x? 1 by e plus t by 1 by e plus t by 1 by e plus t minus 1 by e. So this is t in denominator. So limit t tends to 0 e power ln of 1 plus ln 1 plus et by e, no? So into this is e by 1 plus et, right, by t. So this is limit t tends to 0 e power ln a by b is ln a minus ln b. So ln of 1 plus ln 1 plus et minus ln e into e by 1 plus et by t. So the limit t tends to 0. So e power ln e is 1. So 1 minus 1 is 0. So ln of ln 1 plus et into e by 1 plus et by t. So if you see this is 1 by 1 plus x, right? This is of that form. So 1 by 1 plus x is 1 minus x plus x square minus x cube plus x power 4. If x is, mod x is less than 1, then we can use this geometric progression, so on to 1 minus x plus x square minus x cube plus x power 4, so on to infinity. So as et is small, so this is ln of 1 plus et, also we can use an expansion. So ln 1 plus et, right, when et is very small, so et minus et whole square by 2 plus et whole cube by 3 minus et whole power 4 by 4, so on to infinity, as et is small. So if we substitute that here, so limit t tends to 0 e power ln et minus et square by 2 plus et cube by 3, so on, into e into this is 1 minus et plus et square minus et cube, so on, by t. So what we have is limit t tends to 0. So here we can take et out. So ln et, ln ab is ln a plus ln b. So this is ln 1 minus et by 2 plus et square by 2, so on. into e into 1 minus et plus et square, et whole square, et whole cube minus so on by t. So this is e power x plus y, right? So this is e power x into e power y we can write, and then this, so we are multiplying this and this, right? So this, the entire thing is multiplied by this entire thing. So limit t tends to 0 e power, so this is 1 plus ln t, 1 plus ln t into, will multiply with this, so e minus e square t plus e cube t square so on into e power, because e power a plus b is e power a into e power b, so ln 1 minus et plus et square by 2 so on into, we are multiplying this by e minus e square t plus e cube t so on, e cube t square so on to infinity by t. So if I multiply each and everything, so limit t tends to 0 e power e minus e square t e cube t square so on plus e ln t minus e square t ln t plus e cube t square ln t so on into e power. So let's say if I put et is equal to 0 here, ln 1 is 0 and here e, so ln 1 is 0 into e is 0, so e power 0 by t. So e power 0 is 1, so we evaluated this part, so this part is 1, so this part we are seeing now. So this is, see, t ln t is there, right? So first we'll solve that. So limit t tends to 0 t ln t. So if I want to solve this, so as t is tending to 0, so this is tending to 0, this is tending to minus infinity, because ln 0 tends to minus infinity. So for to evaluate that, what we do is limit, instead t tends to 0, this we can write as ln t by 1 by t, right? So this is infinity by infinity form. So now differentiate this, limit t tends to 0, if I differentiate it, 1 by ln t is 1 by t, this is minus 1 by t square, so this is minus t, limit t tends to 0 minus t, so which is 0. So this term will become 0, this term will become 0, so all this term will go to 0. So what we are left with is, so if I put t equal to 0, so this is e power a plus b plus c so on, like that, right? So we can separate each and every term. So if I separate each and every term, so what we can do is limit t tends to 0, first we'll separate the terms, e power e into e power minus e square t plus e cube t square so on into e power e ln t, and then e power minus e square t ln t plus e cube t square ln t so on into e power 0 by t. So see, this whole term is e power e, this is again e power 0, this is t power e, right? Because t power e, so this is, by using interchanging property in logarithms, we can say that this is t power e, this whole value will become t power e. Again this whole is e power 0, so what we have is e power e, limit t tends to 0 e power e, e power 0 t power e, e power 0 e power 0 by t. So this is limit t tends to 0 e power e into t power e minus 1. So this value is 0 because e minus 1 is greater than 0, right? So I mean greater than 1, because t minus 1, I mean e minus 1 is, e is 2.713 minus 1 is 1.713, right? So 1.713, so on. So t power 1.731 whole power 0 power 1.731 will tend to 0. So e power e is some finite number, but we are multiplying by 0, so we'll get 0. So the value of that limit will be 0.